Okay, so you're feeling sick. The crime scene is your own body, and we've got two prime suspects, bacteria and viruses. Now, figuring out which one is to blame isn't just for fun. It's absolutely critical to cracking this case and getting you better.
So where do we start our investigation? Well, with the clues, of course, your symptoms. But here's the thing. This is where it immediately gets really confusing. Just look at this. The overlap is incredible, isn't it? Fever, coughing, feeling totally wiped out. These are just your body's standard alarm bells going off. And here's the problem. Both bacteria and viruses can trip the exact same alarms. So trying to figure out the bad guy based on symptoms alone, yeah, it's pretty much impossible. All right. Since the early clues are so messy, we have to dig a little deeper. We need to get a profile on our main suspects. You know, what makes them tick? What's their MO?
And this quote, it just nails it. They're as different as giraffes and goldfish. I mean, think about that. Even though they can make you feel sick in similar ways, at their core, these two are playing completely different games with totally different rules.
Okay, first up, let's look at suspect A, bacteria. These guys are the old-timers, the veterans of planet Earth. They're complex little single-celled organisms that have been around for something like 3.5 times billion years. And here's the key thing about them. They're totally self-sufficient. They can reproduce all by themselves, no help needed.
Then you've got suspect B, the virus. Think of this one as a tiny, minimalist hijacker. It's way smaller and much simpler than bacteria. It's really just a little bit of genetic code, DNA or RNA, wrapped in a protein coat. But here's its fatal flaw, its Achilles heel. It's a parasite. A virus is completely helpless without a host. It has to hijack one of your cells to survive and make more of itself. So let's put them side by side in a tail of the tape to really see what we're dealing with. Size-wise, bacteria are giants compared to tiny viruses. Structurally, bacteria are these complex little cells, while viruses are super simple, just that genetic code in a coat. And the biggest difference, the one that changes everything, bacteria can survive on their own, anywhere. Viruses, they have to have a host, and that right there, that's the key to this whole mystery. Now, we have this tendency to think all bacteria are bad guys, right? But that is a huge misconception. Get this, less than 1% of all bacteria on Earth can actually make us sick. The vast majority are totally harmless, and a lot of them are actually our allies, helping us digest food and even protecting us from other nastier germs.
Okay, let's check out their rap sheets. What are these two culprits actually known for? A quick look at their track record tells you a lot about what they're capable of.
Now, don't get me wrong. Both have caused absolute devastation throughout history. The Black Death, that was bacteria, and it was horrifying. But if you zoom in on just the last 100 years or so, a really clear pattern emerges. The biggest, deadliest pandemics, we're talking the Spanish flu, HIV/AIDS, and of course, COVID-19, they've all been the work of viruses.
On a more day-to-day level, bacteria are behind a lot of familiar infections. Their rap sheet includes things like strep throat, those awful urinary tract infections, food poisoning from salmonella, and even things like Lyme disease or nasty skin infections.
Viruses, though, man, their rap sheet is incredibly long and varied. They're the ones behind the common cold and the flu, sure. They're also the cause of what we call the stomach flu, that's usually a norovirus, but they're also responsible for way more serious stuff. Diseases that can attack your liver, like hepatitis, or even your brain and nervous system, like polio and rabies, not to mention HIV.
Okay, so let's recap. We've got two totally different culprits who leave behind the exact same clues. So that brings us to the million-dollar question, right? How in the world do we crack the case and get a positive ID on the bad guy?
Well, this is where the real detectives, the doctors and scientists come in. They know they can't just go by your symptoms. They have to follow a specific process to get to the truth.
Their investigation starts with the basics, a physical exam asking about your history. But if the clues still don't point to a clear suspect, they've got to escalate. That means lab tests, blood, urine, or they might even take what's called a culture. That's where they take a little sample of tissue or fluid and actually try to grow the microbe in a lab to see exactly what it is.
And getting that positive ID, it's not just about curiosity. It is absolutely 100% critical. Why? Because the weapons we use to fight bacteria are completely different from the ones we use to fight viruses. You have to have the right tool for the job.
And here are the two very different arsenals we're talking about. To fight bacteria, our go-to weapon is antibiotics. To fight viruses, it's more of a 1-2 punch. We use vaccines to prevent them in the first place, and then we have antiviral drugs to treat some of them once you're already sick.
Okay, if you remember one thing from this entire explainer, let it be this. Antibiotics do not work on viruses, period. Taking an antibiotic for a cold or the flu is completely useless. It's like trying to put out a forest fire with a water pistol. It just doesn't work.
And actually, it's worse than just being useless. See, every time we use an antibiotic when we don't need to, we're giving the bacteria that are just hanging around a chance to learn and adapt. It's like a training ground for them. This is what leads to antibiotic resistance, the creation of superbugs that our best medicines can't touch anymore. And that is a massive, scary global problem. So, all of this leaves us with a really big, kind of unsettling question for the future. As our best weapons against bacteria get weaker and weaker, the next big whodunit in medicine might not be what's making us sick, but rather, do we have anything left to fight it with?